All right, here we go. This is the last question of the 2018 AB exam, and it's a differential equations question. I love this topic. Tends to be a high scoring kind of place for most of our students. So let's jump in and see what we can do. Consider the differential equation. Differential equation just means an equation that involves derivatives. dy dx equals 1/3 x times y minus 2 squared. Okay. A slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. Well, I'm going to get out two different colors for this. In the middle of the AP exam, you're just going to have your pen or your pencil. That's fine. So find the point 0, 2. Here's x equals 0, y equals 2. There's that point. And the way a slope field works is you are looking at all these little line segments. Those represent your tangent lines at that point. So at 0, 2, what I see is my tangent line is horizontal. So I'm going to draw a curve that is horizontal. As I start to move along the curve, I get to the next point where I see a tangent line. And that tangent line is horizontal as well, so I'm going to continue to draw my curve so that I am horizontal, each time reaching another tangent line, following the instructions there, but they're all telling me the same thing, which is stay horizontal. As I move to the left, stay horizontal. So if all goes well, what you've drawn is just a straight line at y equals 2. You're passing through the point 0, 2, so the solution to this differential equation that passes through 0, 2 is going to look like this. Okay? Now, what about the one that passes through the point 1, 0? 1, 0 is over here. If I look at the tangent line here, that tangent line is increasing a bit, so that's what my curve is supposed to do. As I move to the right, that tangent line gets me to the next tangent line, which is also increasing. And I keep moving along. I get to the next one. I get to the next one. I start to see that they're tapering off. They're not increasing as much, so I'm just going to keep going that way. As I move to the left, I'm following the tangent lines. I'm decreasing because now I'm moving to the left. I'm decreasing, eventually I'm horizontal. Then I start to increase and increase and increase and increase. All I'm going to do is follow those tangent lines. And that's it. 1 point for the first solution curve, a second point for the second solution curve, for a grand total of 2 points. This is the kind of question where I would expect pretty much everybody's going to pick up that point. As long as you've seen the question, you've had exposure to differential equations, you understand what a slope field is, you should be good. All right, let's look at part B. In part B, it says let y equal f of x be the particular solution to the given differential equation, so this differential equation up here, with initial condition f of 1 equals 0. Okay. Some of you might be thinking, oh, it's time, it's separation of variables time. No, keep reading. Write an equation for the line tangent to the graph at x equals 1. Equation of a tangent line. Use your equation to approximate f of 0.7. To find the equation of a tangent line, you need two things. You need a point, and you need the slope. They gave me the point. They said at x equals 1. Well, I also know that if x equals 1, the corresponding y value is 0. So that's my point, 1, 0. To find the slope, I need to find dy dx at 1, 0. Oh, I went off the page, sorry. I need to find dy dx at 1, 0. To do that, I'm going to go to my differential equation. 1/3 times x is 1, times y minus 2, 0 minus 2 squared. That's going to give me 1/3 times negative 2 squared is 4. My slope is 4/3. My slope is 4/3. My point is 1, 0. The equation of my tangent line is 4/3 times x minus 1 plus 0. Of course, you don't have to write the plus 0 if you don't want to. To approximate the value of my function at 0.7, I'm going to evaluate my tangent line at 0.7. I'm not going to bother to simplify because there's no need. Everything's a number. This is perfectly acceptable. The College Board awarded 1 point for coming up with the equation and 1 point for coming up with your approximation. If you are tempted to simplify, feel free. 0.7 minus 1 is negative 0.3. 4/3 times negative 0.3 is negative 0.4. And as I've mentioned several times along the way, negative 0.4 is no better than the answer that you already have, so it really would just be a waste of time. All right, let's move on to part C. In part C, we're asked to find the particular solution to y equals f of x to the given differential equation with initial condition f of 1 equals 0. So we have y equals f of x. Sorry, I got interrupted there. So we're asked to find the particular solution to the given differential equation with initial condition f of 1 equals 0. Finally, they want me to actually find the particular solution. This is when we're going to use separation of variables. We know that the differential equation is this guy up here. dy dx equals 1/3 x times y minus 2 squared. In order to use separation of variables, which is a very common technique, what we need to do is separate the variables using our algebra skills here. dy dx equals 1/3 times x times y minus 2 squared. I want to get all the x's and the dx on one side, the y's and dy's on the other side. So I'm going to do that by multiplying both sides by dx. dy is equal to 1/3 times x times y minus 2 squared times dx. I still have an expression involving y on the right-hand side. I'm going to divide both sides by y minus 2 squared. So we get dy over y minus 2 squared equals 1/3 x dx. At this point, I have successfully separated the variables. I have x and dx on one side, y and dy on the other. This is when we're going to integrate both sides. The integral of 1/3 x, think about it as 1/3 x to the first power. I'm going to add 1 to the power, and I'm going to divide by the new power. So that's 1/3 times 1/2 x squared plus c. Over on this side, I'm going to do substitution. This is not an expression that I would expect that you just have memorized. So let's do u substitution. I'm going to let u equal y minus 2. So du is 1 dy. The expression now becomes du over u squared. Well, du over u squared, that might be something that you have memorized. It probably isn't. So I'm going to rewrite this as u to the negative 2 du. If I use my power rule for integration, I'm going to add 1 to the power. I'm going to divide by the new power. Let me rewrite this. We have u to the negative 1 divided by negative 1, which is the same as negative u to the negative 1, which is the same as negative 1 over u. We're doing substitution. U is y minus 2, so we have negative 1 over y minus 2. Pulling everything back together, we have negative 1 over y minus 2 is equal to 1/6 x squared plus c. I know I just did a whole lot of calculus, a whole lot of integration, but if you are comfortable with U substitution, that's really not too bad. We've arrived at what looks like a pretty good answer, but we're not done yet. We still haven't figured out what the constant of integration is, and we haven't expressed our final answer in terms of x. We want it to be in y equals form. So we've got just a little bit left, just a little bit. Let's use that initial condition. We know that, what was the initial condition? We know that f of 1 is equal to 0. So if x equals 1, y is equal to 0. We've got negative 1 over 0 minus 2 equals 1/6 times 1 squared plus c. Negative 1 over 0 minus 2 is a half, equals 1/6 plus c. If I subtract a sixth from both sides, 1/2 is 3/6 minus 1/6 is 2/6. 2/6 is really 1/3. We get negative 1 over y minus 2 equals 1/6 x squared plus 1/3. Now, what's going to be a little bit tricky for us, not impossible, is we've got to solve this equation for y, which means we need to get y all by itself. And I see that with the y, I'm subtracting 2. It's in the denominator. I've got a negative. I've got fractions on this side. We got all sorts of ugliness happening. So I want to do one of the things that, that I would have learned teaching Algebra 2, or maybe even Algebra 1. Is I want to multiply both sides by 6. You don't have to do this, but stay with me and you'll see why this is helpful. 6 times negative 1 over y minus 2 is negative 6 over y minus 2. Negative 6 times 1/6 x squared is x squared. 6 times 1/3 is 2. I don't know about you, but that already looks a little bit cleaner, a little kinder to me. That y is in the denominator. What I want to do is I'm going to treat this as a proportion. A fraction equal to a fraction. I'm going to cross multiply. Some of you know this is the butterfly method. Negative 6 times 1 equals x squared plus 2 times y minus 2. I'm not going to multiply this out using the FOIL method because what I want to do is solve it for y. So I'm going to divide both sides by x squared plus 2. And now to get y by itself, all I have to do is add 2 to both sides, and I'm going to get negative 6 over x squared plus 2 plus 2 is equal to y. That's your final answer. Now, depending on how comfortable you are with differential equations, you might also want to carefully examine the domain, because the solution to a differential equation has to be a continuous function over its specified domain. X squared plus 2 can never be equal to 0, so I'm never dividing negative 6 by 0. So my domain should be all real numbers, and it actually is. So we're good. Let's talk about how points were awarded, and I'll be done in just 1 minute or less. The College Board awarded 1 point for separating the variables, basically reaching this point without making a mistake. They then awarded 2 points for the antiderivative. So I'm going to say 1 point for coming up with the 1/6 x squared, and then another point down here for where you figured out that the left-hand side was negative 1 over y minus 2. 1 point for constant of integration, and so it's not just writing the constant of integration, but constant of integration and using the initial condition. So getting to here is using the initial condition. And then finally solving for y, which is where we get here, that's your last point. Whether you mention the domain or not, they're going to give you the full points as long as you did everything correctly. So this is a 5-point question. This is huge in the world of the College Board, and I would want you to get all the points here. All right, so before we wrap up, a couple of things I want to say with this is that if you do not, or if you incorrectly separate the variables, you're done. You will get a maximum. The College Board says you can earn no more than 0 points out of 5 if you don't separate the variables. This technique of separation of variables is mission critical for you to understand and master. And then you can earn no more than 3 points out of 5 if you, for some reason, correctly integrate both sides and you forget to write the constant of integration. You will earn no more than 3 points out of 5. So don't do that. And with that, we are done. So let me post this up to YouTube and get you guys going.